Good afternoon, everyone. Today, we have our guest speaker is Dr. Mahmoud Khalifeh from the University of Stavanger. Dr. Khalifeh is associate professor at the University of Stavanger, and he holds a PhD in plug and abandonment of wells with a focus on materials optimization for permanent P&A. Dr. Khalifeh has developed the permanent P&A subject, at a master level at the University of Stavanger. Also, he has published several articles in science journals and conferences. Dr. Khalifeh represents the University of Stavanger as observer at the Norwegian Plug and Abandonment Forum since 2012. So Dr. Khalifeh is going to present the well integrity and well abandonment for green transition, geothermal energy. Thank you so much, Dr. Khalifeh, for being with us, and please, the audience is yours. Thank you.
Thanks a lot. I really appreciate. Thanks everyone for the invite and for the time and for joining. I hope that we can have a kind of constructive session together, learning from each other. I have been instructed that the questions comes at the end, but please feel free to unmute, ask your questions along the way if you think that you need to get clarification. So a little bit about myself. We have, with my colleague Audrey Sawson, we published a book in 2020, and I'm not quite sure if you guys have had the opportunity to download the book and read it. This book has been published as open access, means that you can download it for free and read it. I recommend it because actually you get lots of insight about well integrity and mainly well abandonment. And as you can see, I mean, it was globally downloaded several thousand times, and that's encouraging. A little bit about my university. Yes, I work at the University of Stavanger. Those that they are familiar with Norway, they know where Norway is located. I will show you a Europe map. This is actually our campus area, and this is north, and this is a drilling rig which is used for doing research. For your information, Norway has no onshore wells. All the wells are offshore. I'm coming from Faculty of Natural Sciences, which is actually here, located here. And we have a sweep or lab subsurface well integrity and permanent abandonment, which is located in this part of the building. And then a little bit about Norway. Yes, this is Norway. We are located south part of the Norway. And this is the area which our university is located. Most of the oil companies are located in Stavanger, the same city as our universities. And for us, it's an advantage because by driving only 10 to 15 minutes, we can meet people in oil companies. And then Norway has only offshore wells which are located in this area. If I want to show this area. And yes, this is the North Sea and this is Barents Sea. One of your classmates, actually, she started to do her master at our university. And if you want to learn more about our university, you can contact her and learn about the university. A little bit about a kind of collaboration which we have with Oklahoma University. There is SFI, a research center called SWIPA. The research center is actually studying or trying to study subsurface well integrity and P&A. We have NTNU, UIS, Norse, IFE, and SINTEF as partners, scientific or research partners, Norwegian, and then Oklahoma University is actually an international partner here. So we are looking for collaborations. Feel free to contact us if you guys you would like to do projects with us or you would like to have a stay abroad in Norway. Said can provide you with more information in that case. Yes, a little bit about the topic that I'm going to talk. I was trying to create a presentation which can cover well integrity and well abandonment connected to geothermals. And then I said, okay, let's have another way of thinking, thinking out of box, because we have different types of wells. It could be CCS wells, it could be geothermal wells, it could be hydrocarbon well, a lot of wells that we can actually categorize, and then injectors and so on. And well integrity is important for all of us. And then some of these reservoirs which have been depleted, they may be a candidate for another application, of which we call it repurposing. So if we want to do plug and abandon on those reservoirs, how we should do it to make sure that they're not going to leak, or we can reuse them in the future if it's necessary. To address that, then I need to talk about caprock functionality. I will explain what do I mean by that. Then I will continue with two barrier philosophy, which is used in well integrity and well abandonment. I would like to talk a little bit about challenges associated with drilling in high temperature wells. Then, if we get some time, I'm going to talk about P&A, its objectives, and the wave of P&A, and associated challenges with P&A and plug and abandonment. So, assume that this is your reservoir. It doesn't make a difference if you want to call it as hydrocarbon reservoir, or you want to call it as a geothermal, or CCS. Okay. As long as there is a formation which contains the source of energy you're looking for, and there is a caprock on top of that, then this is a reservoir. Means that the source of energy has been trapped and cannot escape. Okay. So, but what happens during drilling? Actually, the drill bit penetrates the caprock and enters the reservoir. What we have done, or what we do in the reservoir section, is not of interest with respect to well integrity and P&A. What's important is the area where you have the caprock. If you could maintain this area, caprock functionality, then this reservoir is secured and you can produce the type of energy you're looking for. Okay. Sometimes we have different wells drilled from the same area, which is actually a platform. And then we penetrate the caprock either one time or two times at the same depth. Okay. And we need to ensure actually well integrity in this area, which is caprock functionality. Let's talk a little bit about what was the real scenario. You have a reservoir, okay, a source of energy, which was protected by a caprock. Now I'm talking about hydrocarbon wells. When we drill the caprock, through the caprock, we establish a barrier. Usually it's shown as blue, and we call it as primary barrier. The primary barrier, which you see here, is always engaged and in contact with the main reservoir, the source of pressure. And remember, pressure is your enemy. If you can control pressure, you maintain well integrity. If pressure controls you and your activities, then you lost the well integrity. And we as human beings, we have learned that whatever can go wrong will go wrong. That's Murphy's law. And primary barrier may fail. What will be your course of action when the primary fails? Therefore, we use a backup barrier, which is usually showed in red, and it's called a secondary barrier. So I call this one primary barrier, and then the red one secondary. It's important to mention or emphasize that primary is always engaged, but secondary will engage when primary fails. If you look at the shape of this blue curve, it's like a hat. And the second one is like a hat over a hat. Sometimes we call this type of barriers as hat over hat barrier. And we have been familiar with it since day one when we started to do drilling. Actually, as you can see here, in this part of the figure, when we construct wells, we use drilling fluid as the primary barrier. Therefore, it's shown as blue. I need to ask a question, and why fluid was acceptable as a barrier, or is it acceptable barrier element? No. We should say fluid is not a barrier element unless there is BOP in place. Why? Because fluid can be displaced. Fluid can get attacked by gas. But as long as you have BOP in place, BOP can control the source of pressure for you. Okay. And remember, we don't have any other option. We cannot select any other barriers, even if you had different casing strings, because as long as the wellbore is open and you do drilling fluid is your primary barrier. However, after drilling, when we do completion and we start with production, since then, we do not accept fluid as a barrier element. Okay, a well barrier, which I showed in the previous slide here, actually is consisted of different elements, as you can see, different components. It can be a formation, which is a competent formation, like caprock. It's cement, it's casing shoe, casing, all the way up the packer, production tubing, its connections, downhole safety valve, and all the way back. Okay. As you can see, we have different types of well barrier elements with different properties. Some of them are cementitious, some of them are metal. And that makes our task a little bit difficult because they have different lifespan. During well intervention, also, we had primary and secondary barriers. When we have your vial and BOP, as you can see, the situation gets more complex because the blue, which was hot over hot, actually goes over red. That makes it a little difficult. Even with PNA, when you do PNA and post PNA, you have primary barrier, secondary as a backup, and a plug, which we call it as environmental plug. Remember, I do not call this one a barrier. It's not a barrier. Why? Because a barrier has a definition. Let's focus on this case, production. Assume that you have a wellbore and you're trying to produce and you need to establish your primary and secondary barrier. As you can see, this formation is capable to hold pressure because it's a caprock. Okay? Casing shoe, production casing, usually placed in the caprock. And then when the source of the pressure comes, the caprock is able or capable to hold the pressure for you. Casing cement, casing by itself, and all of these components, they are capable to hold the pressure for you. If this primary leaks, the secondary leaks, source of flow comes underneath of your environmental plug. Okay, plug is strong enough because it could be a cement plug. However, the formation, adjacent formation, which is in a shallow depth, is not competent anymore because it's not capable to hold the pressure for you. So the source of flow comes here and then breaks, formation leaks to the surrounding. Type of barrier could be cement from rock to rock in an open hole, or it could be cement formation, cement, casing, production tubing. Moving forward, what are the consequences of loss of well integrity? You guys, you work with geothermal energy. Okay. We don't have so many wells, geothermal wells, compared to oil wells or hydrocarbon wells, but there will come a time where the number of geothermal wells will be much more than oil wells. Either oil wells, they're gonna get closed, a number of geothermal will increase, or all of the hydrocarbon wells will be closed completely and few geothermals that will be available in the market and producing energy. The fate is that oil hydrocarbon wells will just die out or phase out. Okay, but I would like to get your attention on some well integrity issues which happen to hydrocarbon wells. And we don't have any, I couldn't find any actual incidents on geothermal wells so far, few well integrity issues, which they were not actually dangerous. But we should expect them to happen because the number of geothermal wells will increase. Okay, you guys, you're familiar with Macondo. Okay? For sure, you had it in your courses, and you have seen the movie, you have read the report, and you know lots of things about it. Why cement was not qualified, and then it was assumed that it's qualified, and then the barrier failed. Actually, this is a consequence of barrier failure. US. I go to Africa. See, oil is leaking to the surrounding. I go to the UK sector of the North Sea. I go to Florida. If I remember, this one should be Canada, and this is Iran. Okay. What I'm trying to say, well integrity is not a concern only in one country or in one location. It's everywhere. As long as you have a well bore and there is a source of pressure, no matter if it's carbon dioxide, if it's geothermal energy that you're trying to produce, or it's hydrocarbon. Regardless, that could be a concern for us. But in this presentation, I'm going to review well integrity and permanent P&A, and then we will expand it a little bit, why they are connected together. Okay. Let's focus on well integrity. So, well integrity operating philosophy is that we have to manage, or it will tell us how to manage the risk of loss of containment. Loss of containment. As long as you have control on it and you know where the fluid goes, you have or you maintain the well integrity. And overexpose oneself with additional risk by frequent well visit and intervention that brings exposure to the people and environment by doing these activities. So it engages both people, human being, and environment together. PSA, Petroleum Safety Authority of Norway, publishes reports every year, which we call them RNNP. This report is in Norwegian. Sorry for that. This is Norwegian, and it's Norwegian. It's English, but this one, yeah, this is Norwegian. And every year, you will just refer to the website and find the report from the year before. It shows that the number of incidents with major accident potential, which doesn't include helicopter or chopper, okay? As you can see, the number of incidents offshore Norway decreased over years, which is encouraging, and tells you about what kind of incidents we had. Okay, it's a construction damage, it's a kind of leakage, or it's damage which happened to the pipes or equipment. So you have overview of different incidents over years. Okay, moving forward, actually you can find number of well controlled incidents as well in the report, which is interesting because for exploration wells, you see that incidents, well controlled incidents, is much higher than the production drilling. Why? Because when you do exploration, you are not familiar with reservoir. There are lots of uncertainties, and you need to drill in a dark room. That's what happens. For production, you are familiar with the environment, but it doesn't mean that you're not going to have any incident. As you can see, there has been incident, and the number was actually, the rate was changing or varying over years. Moving forward, focusing on the wellbore by itself, a study was conducted by Birgit Witness in 2006, shows that there are different challenges associated with well integrity of production wells and injection wells. As you can see, well integrity is not only about cement. It includes wellhead, annular safety valve, casing, pack-off, all the way to the formation as well. Sometimes you can frag formation by accident. Interestingly, you see wells, number of wells, and age. Wells are older than 20 to 24 years or 30 years. They have less well intake issues. That's not correct. The conclusion from the paper was that of the industrial experience is that when you have well bores which they are old and they have old well design, you don't gather information that often from them. However, in new well bores, you have a smart wells equipped with different instruments, and you can actually log data. You can log information, digitalize them, and document them. However, for old wells, you don't have. And some of these old wells, old wells, they have been left for some time, and even they are in a temporary abandoned status. There is no monitoring on them, and we don't know what's happening. Sometimes we have plugs in the tubing hanger, and there could be pressure underneath of the tubing hanger. Even when you open the tubing hanger, you remove it, you expose your personnel to hazard. Exactly what happened in 2018 in the North Sea, Norwegian sector. The drill pipe moved out of the well for 8 meters. They were lucky that no one was lost. So a little bit about the number of wells and well integrity issues. As you can see, tubing tubing creates lots of challenges, and it's the most one. And that's actually what we expect, because we use tubing to avoid damage to the production case. We can change tubing, but we cannot change production casing. Gas lift valve, okay? And remember, this data is for the wells studied, not all the wells in the North Sea. There have been issues with cement, with casing, packer, and wellhead. I usually give examples to people. For sure, for geothermal, you don't have the same challenge, but you will be faced with this challenge in the future. As well, when we go deeper and deeper to this explore energy from high temperature reservoirs. Old days in the North Sea, we were actually putting BOPs on the wellheads, which they are 50, 60 tons, metric tons. Nowadays, we put BOPs actually on wellheads, which they go up to 400 metric tons as a weight. Okay. And we give lots of stresses during the production. We have sea current, which is giving fatigue to the wellhead, and so on. Downhole safety valve. Guys that they are familiar with the functionality of downhole safety valve and how it works, they know that there are lots of mechanics in it. It's a flapper, correct? It has a spring, correct? But you have production, you introduce erosion to it, you add scaling to it. So it doesn't work actual response on demand. Therefore, you have such a kind of issues. As you can see, there are lots of well integrity issues that you can raise, but doesn't mean that you're going to experience them in every well. That makes your job difficult. You are working with one well on one reservoir, and then you get relocated to a new reservoir, but you're not familiar with actually the well bores. And even sometimes you don't know what are the completion of those wells. Okay. I have mentioned that resolution is evolution. When you see this data, you know that you have to focus on some of these which have more frequency, or they are more frequent to happen. And then you can actually start to consider them, or you should pay attention to them. So resolution is really an evolution in your case for your activities. Facts are facts. Okay. I don't expect formation to be damaged more often during the production. Okay. But it doesn't mean that when you produce from Ecofisk, when it subsides 8 meter, then you try to inject and then you put this subsidence back to its almost its original situation. You give lots of stresses to the reservoir and overburden on top of that. And when you go with geothermal or carbon sequestration, it's the same. You increase the reservoir pressure, okay? You increase the pore pressure. A depleted reservoir, okay, starts to get lifted up. And then the minimum horizontal stress is enough for you to get a leakage through the formation all the way up. Monitoring. Okay, we are not in the 80s. Now we are in 20s. We have lots of technologies. We have lots of tools, instruments, which we install in our wells, and we make or build smart wells. lots of sensors, they gather information. Okay, someone is sitting there, you should be there to review those data to see that what's happening, what those data they're telling you. Knowledge sharing company and other companies. We have in Norway well integrity forum where actually experts from well integrity field, they sit together, they share information, because well integrity means, sorry, I'm not quite sure if you can hear me, or because I got disconnected apparently.
Yes.
You can hear me. Okay, great. Because I got disconnected. Okay, most likely it was the AirPods. Okay. So moving forward, knowledge share. If you get opportunity to work on well integrity, remember you should sit with other people, other experts from other companies, and share information with them to learn from their experience from the past and the current situation that they are. Having a tight contact with regulators. Okay, when it goes to carbon sequestration or geothermal wells, actually we don't have that much regulations in place, and that's one of the shortcomings. But we can transfer the knowledge gained from oil and gas industry actually to geothermal and CCS, and we can tell regulators that it's time to get standards in place on how to control the fluid and so on. And remember, we need to update our knowledge. Knowledge could be taking course, attending a conference, or talking to people and inviting them for talks. But well, integrity is a kind of sector that you need to be updated. You cannot just working on reservoirs and say that, okay, I have control on the fluids. No, it's a dynamic system. Talking about well integrity, usually in Norway, and I believe it's the same in the UK sector, we categorize wells in different colors from red, orange, yellow to green. Green means that the well is healthy, there is no integrity issues. When we have one barrier actually degraded, then we consider that one as yellow. And remember here, by the meaning of barrier is not the primary. Actually, the standard they are referring to element, well barrier element, which it could be casing, cement, casing section, and so on. And then the other elements are intact. But if one barrier failed and the other one is intact, but a single failure may lead to a leak to surface, then we categorize the wellbore in orange. I will explain to you how we come up with the color in the end when we have a wellbore. But before that, I need to give you some numbers about the active wells. This is actually RNNP from 2020, which I got a few days ago from Petroleum Safety Authority. And they say that in the Norwegian sector of the North Sea, we have around 2,080 wells active. Since the first discovery in 1967, we have drilled more than 7,500 wells. Compared to US, is nothing. You guys, you have million wells drilled in the last 100 years, past 100 years. Okay, as you can see here, it shows that wells with injection, majority are in green, some of them are in yellow, and few are in orange color. Wells in temporary abandoned status without monitoring means that they left the well over there. There is no monitoring, no one checks them. When they went to check the well just by accident, they found out okay, few of them are in red color, and then majority are in green. We have two different types of temporary abandoned status, which we call it temporary abandoned with monitoring and without monitoring. Means that in monitoring, we actually log pressure and we test barriers regularly. What's the definition of regularly? No one knows. Sometimes some people they do it every year. For some other wells, people they do it every 6 months. And then moving a little bit forward, survey of temporary abandoned status. I would like to have your attention. As you can see, the number of wells with the red category actually increased in 2016 and then decreased in 2020. Uh, Remember, these color changes, they are result of probabilistic simulations. Okay, if you change a regulation or if you change a parameter, then your simulation will change and you may actually fall to red or to orange or to green. So it's not only about you have your barriers in place, but sometimes it's about the input you give to your simulations. And yeah, moving forward, I would like to discuss a little bit or expand now how we come up with the color. Okay. Usually we start with the well barrier schematic as we show it with, or we call it WBS. A well barrier schematic, Wellbore schematic, sorry, a Wellbore schematic is like this one, which shows the wellbore in a vertical position, although we know that we have inclination and we will write inclination next to it. But the aim here is to show the wellbore design. And where are the top of cements, where are the formations with flow potential, and where is the reservoir, and so on. We put all the elements there. After we make the wellbore schematic, we create a well barrier diagram. How it works: you have to put your reservoir, and then you have to select your primary barriers. Okay, when you select your primary barriers, you put all the elements in your primary barrier in the in a column, as I have done here, as and you can see. Then from this point, it's like a game. You should say, okay, this reservoir can expose my production tubing below the downhole safety valve. Okay, if it leaks, where the leak goes. Yeah, the leaks can go in different passes. And then you have to identify all of these passes, all of them, and write them down. And all the time you have to end to the surrounding. Okay. And sometimes this surrounding could be surface, or this surrounding could be a formation in the overburden. And you have to specify what do you mean by surrounding. And when you have all of these leak passes, you go with fault tree analysis. Okay. This is a very simple definition of what is fault tree analysis. Means that for every component in your well barrier diagram, you will allocate a number and you will say, okay, what are the consequences to the problem? Okay. Usually you have a top event, okay, and then you have to find out, okay, how is this top event is going to happen. As an example here, you can see that there, if I assume that if there's a leak on the in the downhole safety valve, actually the leak goes to the hydraulic failure, leads to hydraulic failure, and it can give me downhole safety valve malfunction. Okay. After that, when you have the fault tree analysis, you allocate a range of numbers to each top event. And then you do simulation to find out, okay, what is the risk? I have here some photos to tell you this well barrier diagram that you see is more detailed, or more actually should be more advanced than you imagine, because you may have corrosion in your production tubing, you may have actually poor cementing job, or a combination of good and poor cementing job. You have lots of connections in your casing, and then casing could be corroded, cement could be corroded, your cement casing can be debonded, cement formation can be debonded, and then all the way to the wellhead. People usually write wellhead. No, wellhead is just a component. You can't write wellhead. Wellhead has lots of valves, has lots of connections, ceilings, okay, and lots of tubing hangers or casing hangers. All of these together. We don't want to have any leakages from this one out. Okay, so you have to give a number to every component. People that they have experience, industrial experience, they will tell you, for example, how often you should expect to get the leak from the, for example, connections or from the starter head and so on. All of those numbers, they come and then they give you a kind of color which you could see in the previous slide. So that's not a straightforward task to be done. A little bit about now geothermal wells. What kind of well intake do you should expect? Talking about Iceland. Iceland is a special case, but that's an interesting case.
Equinor is active in Iceland doing lots of research, and we are in tight contact with people at Equinor and also researchers. When we do drilling in Iceland, usually the temperature is around 500, 550 degrees C. That's a really high temperature. And we do drilling with no return. Means that we just pump fluid to push the cuttings to the reservoir or to the formations, and then we don't get any fluid out during drilling. In this way, actually, temperature from 500 to 550 falls down and goes to 50 degrees C, vicinity of the wellbore. Okay, now your situation becomes complex. You are on loss of drilling fluid because you do drilling with no return. At the same time, you cool down the vicinity of the borehole. Okay, now you need a cement. This cement is tricky because if you make it for high temperature to survive high temperature, it's not going to set at low temperature at 70 degree or 50 degree. If you make it set at 50 degree, then it's not going to tolerate 500 degrees. That's one of the challenges. Number two, elongation of casing. You place your casing in the wellbore, okay, the temperature is of 70, 60, 70 degrees C. And then the reservoir starts to build up its temperature to a geothermal gradient, which it had, which is around 500 degrees C. Elongation of the casing actually is one of the challenges that you have. On top of that, annulus pressure, because you have trapped fluid, okay, and then the fluid starts to expand and then can create a kind of collapse scenario for you. People, they have been trying to use LCM products, but LCM products actually, depending on the temperature, some of time they are not effective. They get degraded or they're expensive to be used. Um, if you guys pay attention to the temperature gradients which are in Europe, Iceland is a rare case. In other countries, usually we are talking about 100 degree, 150-degree Celsius, and that's a temperature which we have experienced most with. Talking about well integrity and temperature, I remember a report from Australia when they drilled the well and they did miscalculate the casing elongation due to the temperature changes. And when the well was completed, the well had moved around 2 meters above the ground, and that was a mistake which engineers they made. Okay, moving a little bit now, I would like to talk about P&A. Why is P&A is important for me? It was a person contacted me, said that we have actually hydrocarbon reservoir depleted. We have plugged them in 70s, and we are trying to, and we found out that they are good candidate for CCS. And I want to review the well barrier schematic and wellbore schematic and barriers to see that if we can inject CO2 to reservoir without getting a leak. So the reservoir was depleted. The reservoir is a good candidate for repurposing. The concern was actually how the wellbores were plugged. We reviewed the data, and the conclusion was these wellbores, they have been plugged and abandoned in an appropriate way. Whatever you inject to the reservoir may leak to the surrounding, and you cannot use the reservoir anymore. There is no repurposing. And if you want to re-enter the wellbore and do plug and abandon on all of those wells in the field, you have to consider the cost significantly. Okay, so what's the concept or philosophy behind P&A then? How should I do my test? Actually, as I said, we are not concerned about the reservoir section because reservoir section is a porous formation which fluid can move in different directions. What you have made or we have made as drilling engineers, we have penetrated the caprock. If we can restore the caprock or wherever that you have a caprock, because sometimes you have fluids in the overburden with flow potential, but with a small flow potential, sometimes with no flow potential. However, if they contain hydrocarbon, you have to restore the caprock for them as well. And That's the reason that we actually place primary barrier and we place secondary barriers. And sometimes you need to have two primary barriers, and sometimes you should have, or combine, you can combine them and have one barrier for both, for all of these well bores. Okay. But what I'm trying to say is that in the future, when you construct geothermal wells, you don't expect to do plug and abandon on those wells because you have to gain energy from it enough because you have invested on that, and you're talking about sustainable, okay, production. But remember, you will experience sooner or later some wellbore integrity issues or well integrity issues, which you need or may be forced to do permanent P&A on the wellbore to sidetrack, okay, and then start to work on the new wellbore. But you need to permanently plug and abandon the original wellbore. The question is that do we know really how we have to plug and abandon geothermal wells in the future when we want to make a sidetrack? And to be honest, we don't have that much experience with them yet. When talking about plug and abandonment of reservoirs, usually they are regulators, which they will tell us how the job should be done, but not in a straightforward manner. Yeah, they're not gonna tell you how to do it. They want to tell you how or what they would expect from you. Interestingly, Petroleum Safety Authority of Norway, which is a subcategory of NPD, Norwegian Petroleum Directorate, it's a good example, says that give the reservoir back to me the same way as I gave it to you. That's really interesting. How did you give it to me, and so that I can give it back to you the same way? Uh, Actually, they say restore the caprock or its functionality, and that's where your challenge starts. Caprock was penetrated by bit. I had I placed cement, I placed casing. Sometimes even I don't have cement behind casing. How should I do that? And working in petroleum industry or maybe geothermal or CCS in the future, you guys, you need to know where you are. If you have the mindset from Norway moving to US, I doubt if you can do a job or get a job because vice versa from US to Norway. Yeah? Talking about experience, I was working as a consultant for a company, an operating company, and then they sent some engineers from US because the company was an American company. Yeah. So we went for a tender and they said that okay, make your P&A designs for our well bores. We made the P&A design and they said, no, we don't want this design because this is more expensive than what we thought. So in US, we do it in another way. And then I said, okay, how you do it? They said, we just place cement inside casing. I said, no, we cannot place only cement inside casing. We need to ensure that we have a competent barrier from formation to formation, and that should be a competent formation. Anyway, they insisted we delivered the report, and interestingly, those guys, when they submitted the report to PSA, Petroleum Safety Authority, after a few months, they were sent back. I don't know why, but for sure, someone could make a guess why. So, what I'm trying to say here is that moving from one country to another country, you need to know rules and regulations and standard for plug and abandonment. In Norway, we have PSA, as I said, and PSA stands for Petroleum Safety Authority. And interestingly, in Norway, we have a standard. Usually, people they think that this standard is a regulation, which is not. Is a misunderstanding from people. This is only a standard drafted by operating companies and service companies to help those companies which don't have much experience with well integrity and well abandonment. That's the case. So who made it? As I said, experts from operating companies and service companies. PSA, or Petroleum Safety Authority of Norway, has its own regulation, which is only 2 pages. Section 48 on well barriers and Section 88 securing wells. Making an abstract of those 2 pages, Give the wellbore or reservoir back to me the same way as I gave it to you. Okay. So then why we have Norfolk DO10? Actually, this is, as I said, a help to the companies. And interestingly, Petroleum Safety Authority and myself, I'm sitting at PAF as observers. We look at industry and we learn from them how they discuss what are the arguments, what are the reasonings behind suggesting or proposing such a kind of solution or approach in the standards. And the standards they develop over time. Okay, this standard that you see, Norfolk DO10 version, actually 2021. When I started to work on well abandonment in 2012, it was only 50 pages. After almost 9 years, this now is around 250 pages. Means that we learned a lot from well integrity and P&A. We learned a lot about how to test barriers, how to qualify them, and how to interpret the data. Okay. So, question: do we have standards for geothermal wells? Up to my knowledge, there is no one. Okay. And my experience tells me that we should not wait until we drill many wells, a million geothermal wells, and then thinking about, okay, we need a standard. No, we have to think about it, say that if we want to construct wells, we have to follow standards, although every well is unique. And we have to construct them in a way that in the future we are not going to put too much efforts on them or money as an investment for abandoning or creating sidetracks and so on. This is what we need to think of. I'm not quite sure how is it in globally actually in this case. Talking about P&A, plug and abandonment, people they are panicked, say that oil is phasing out, we lose our jobs. What should we do, Mahmoud? I told them, don't be scared. P&A wave is coming. It has been out there, and the wave gets much larger now. Okay. P&A, plug and abandonment, is a gigantic market. Okay. As an example, since the first discovery in the Norwegian sector of the North Sea, we have approximately drilled 7,200 or 7,500 wells so far. Of these wells, we have around 5,400 development wells and 1,800 exploration wells. Those working in the field of petroleum, they know all of these exploration wells, regardless if they hit the target or they are dry, they will be permanently plugged and abandoned, okay, after data gathering. Around 3,000 wells, they are in a temporary abandoned status in Norway, and we have around 500 abandoned wells, okay, permanently abandoned wells. Approximately, we have around 1,800 to 2,000 live wells, depends on before pandemic, after pandemic, and so on, lots of discussions. But looking at the numbers, we get around, as an average, 132 wells drilled per year. Means that if we want to do plug and abandonment as an average, we have to drill approximately 100 wells or 60 to 100 wells a year moving forward. Okay, in the North Sea, we use around 20 to 60 days to do a plug and abandonment. And as an average, we say that, okay, a well is going to take us 30 days. If I have a rig and the rig can do actual P&A on 12 wells, then it's equal to 1 year. Then the question is that how many rigs do I need to plug and abandon all of these in one year? Or if I do plug and abandonment every for 50 wells every year, how long does it going to take for me to plug and abandon all of these wells? Working in the field of well integrity and especially well abandonment, I want to tell you, in the North Sea, if we decide to plug and abandon all of these wells which we have active, and those that they are in a temporary abandoned status, we need to do plug and abandonment for the next 20 years, at least, for the next 2 decades. And that's the market for people. Yes, several factors affecting the wave size. Guys that they are following climate change and COP26, they know what happened. even with coal, which we got disappointed. We thought maybe coal is going to phase out, but they said it's going to phase down. And then corona situation or pandemic situation arrived. Many wells, they went on a temporary abandoned status. Suddenly, after the pandemic situation, the oil price increased to $80 per barrel. And then we saw, wow, people, they started to produce. And then the number of active wells increased significantly. But remember, we shall wait and see what is or what our NNP report is going to say in 2021 for in 2022, because these wells that which they were in a temporary abandoned status, for sure they had some kind of pressure somewhere which we were not aware of. During opening these wells or reopening these wells, we may experience lots of incidents. So this wave, P&A wave, which is affected by climate change, by attitude of people and facts of environment, actually give us a hint that the market is huge and we should be ready for it. At the same time, people that are talking about CCS technology, they say that, okay, we have to store CO2 somewhere, and these reservoirs, they might be a good candidate. Means that we need to do a good job so that we can use or reuse these wellbores. So challenges with plug and abandonment, there are lots of factors actually which they create this wave much bigger than we assume, because when you spend more time on a wellbore means that you don't have a rig free to do the P&A on the other one. The challenges, I can say, lack of data. Interestingly, even wellbores did in 2000. We don't have that much information about them. And I'm puzzled because I'm in Norway and lots of data are available. People, they are really good in documenting information, but we lack lots of data. And those data could be or is cement, type of cement, quality of cement, annulus pressure, and as I said, documentation. People, they have constructed the well, they use drilling fluids in front of cement, and we don't know what kind of drilling fluid is on top of cement, and we cannot recirculate them, and even we cannot handle them. Old wells or orphan wells, you guys in US, you have lots of orphan wells. People, wells drilled, produced, and left behind, and no one is the owner of the wellbore. Old wells which they have severe well integrity issues. As I said, you can start from the Christmas tree, go to the wellhead, from the wellhead go to the tubing hanger, all the way down to the reservoir. Lots of issues. And subsidence. As I said, Ekofisk field in the North Sea subsided, the whole reservoir subsided 8 meters from the seabed just because of the production. And then lifted up by injection. Well designed. In the past, we were pumping cement to the previous casing shoe. Nowadays, we pump only 200-meter measured depth of cement above the casing shoe if there is no source of flow in the interval. And then lack of annular barrier. As I said, type of cement is not at the right depth. Even sometimes we don't have any type of cement, to be honest. Wellhead fatigue. These wellheads which we use or we are using nowadays, they are old. They were designed for 50 metric tons, 60 metric tons, but not for 400 metric tons. And lots of issues, not only these technologies issues, but also about barrier materials. People, they come with new technologies, say that I have a new barrier material, you should use it. And then industry or we will ask you, how good is the technology? How competent is the technology? For how long is it going to stand there? How does it create a bonding to formation or casing? And then so on. And nowadays, people are talking about bismuth, which is a metal used actually inside casing, and then it expands up and cooling. Lots of things are happening to cut down the time on plug and abandonment and to ensure that we do our job properly to deliver actually these reservoirs or this environment to the next generation in a safe manner. But we learned a lot because we learned that we need to drill new type of wells. and we need to apply our knowledge to new wells. Therefore, we call it green transition. We need to either to reuse or repurpose these wells, reusing the reservoirs, or thinking about new wells with new source of, let's say, with new reservoirs like geothermal. It brings me to the last slide of my presentation. Sorry, because I was a little bit early in the morning, a little bit tired, but I tried to explain as I could. Now I'm open to questions.
Okay.
Thank you so much. Thank you so much.
Okay. Thank you very much. So, okay.
If you have
Mahmoud, thank you for presentation.
Thank you so much. I'm sorry if it was not that consistent
No,
because
it's was great. So if you also agree, I give that homework you had from last year to them, or do you think it's is not fitting the lecture?
no, it does actually does.
Okay,
That's going to help them a lot, to be honest,
sure.
because I that you guys you're focusing on well integrity and geothermal wells. That it will help them to get their hands on real data, and even reviewing the exam is going to help them a lot to learn. Not because I
Sure.
made the exam, now because I got the data from industry, and they're not that old.
Yeah, I wanted to kick off discussion about the well integrity, specifically for geothermals, which you slightly touched about it. And they are also having a project, for using evaluation the oil and gas wells for geothermal application. And one of the things we're discussing is, using these wells, because you are going to inject and produce, so you have a lot of cycle of heat, on these casings, and cement.
Exactly.
And and to me it's a concern because nobody has done this before, other than uh, thermal recovery wells that they have drilled for enhanced oil recovery. The oil and gas wells are not designed for this type of application. I just want to see, what are your thoughts, or what are the consideration that they have to do, in terms of these type of applications, or any concerns.
Yeah, actually, that's a good that's a really good question, because if you drill a geothermal well to inject from one wellbore and produce heat from another wellbore, that's not a concern. Okay, because we know about how cement casing connections, how they're gonna behave. Because you have a fixed temperature. Let's say that you have cooling effect in the injector, and you have, let's say, thermal shock on the producer. But when it goes to half and puff technology, for example, which in the past was really, I think it's still in Canada, they're using this half and puff, yeah? If that is the source of geothermal, which you cool down the wellbore and then you try to inject to produce, I doubt if you can really succeed, especially from the old wells, because you give lots of thermal shocks to the casing, and then you stretch the casing, and then you get debonding from cement, not only cement, even from reservoir, from the adjacent formation. That's a challenge, and I believe that's one of the challenges, that we don't know even how to use the old wells, because you inject fluid, but you want to recover heat, and you're talking about an expensive wellbore, which you're trying to produce a cheap energy. Okay, how much money you put on the wellbore, and then you try to do remediation jobs? Uh, that's a big question. But I doubt if you really can do half and puff technique for geothermal on old wells, because of lots of issues. Ceilings, as I said, thermal expansions, debonding from formation cement, and even having control on the reservoir. Because we have done lots of bad things to the reservoirs. Yeah, we add, we injected acids, we injected fluids, we injected gas, and remember, compatibility of water and formation. When you inject to the reservoir, really, are they compatible? Can you get the injected fluid back, or are you going to have a scaling? And then on top of that comes the scaling, because scaling is the issue, especially when you have water, oxygen, salt, and then that's it. You get plugged, let's say, production tubings. That's what I see as a challenge, Said, and it would be real nice if your students,
Yeah.
they work on it.
Yep. They are looking for 4 wells, for this project, and the well integrity is one of the aspects they have to look in detail. So that's why I thought we raised this discussion here. Do you think there is any any specific, let's say, evaluation that needs to be done on the cementing side to be see if it's suitable for this application?
Yeah, actually, what we have done recently, we put cement inside UCAs, and we gave thermal shocks to the cement, and we characterize the property of cement. So it's not only about cement side. If it was me, I would even draw their attention to the, as I said, to the thermal shocks which you give to the casing and ceilings in the production tubing, all the way to the wellhead tubing hanger, and through the Christmas tree. Because you give lots of thermal cycles, and I doubt if these type of metals, not only cement, forget about it, because it's few cycles, it will be gone. Even the metals, because how much does it cost about to drill a geothermal well, and then how much does it cost to produce energy per kilowatt, if we call it as energy kilowatt hour, how much you gain if you produce it. So there are many years that you need to produce energy from a wellbore until so you can recover the cost. And I'm not quite sure during that duration, when you are using an old well, even formation is not capable to hold it, because you give lots of stresses.
Yeah, yeah. I think that's a very important risk, so to be considered. Yeah. Thank you. Let me give it to other
Thanks a
students
lot.
to ask.
Yeah, no, very, very, very important point. I also, I had this question of pump of operations, and especially wells that are planned to last in operation 30 years. So, yeah, that was a good a good discussion. I have another question. Is also, Dr. Salehi mentioned the idea to use former oil and gas wells. Most of those wells are okay, or P&A, plugged and abandoned. So is it feasible to resort? Okay, or is it? What are the constraints to reuse a well that is already P&A?
So that's a good question. To address that question, then I need to tell you about 3 phases or 4 phases which we define for well abandonment. Okay.
Mm-hmm.
Usually we call a well abandonment as phase 0, which is data gathering and well intervention activities. Phase 1, which is actually a reservoir abandonment. Phase 2 is intermediate abandonment, and phase 3, which is wellhead cut and removal, wellhead and conductor. What happens in reality? If you do a thorough P&A job according to the current standards, you cut and remove the wellhead and the conductor. So if you're going to re-enter the wellbore, where are you going to put your BOP then? Because you don't have any wellhead, you cannot put the BOP on wellhead because there is no BOP. In reality, the definition of P&A, or plug and abandonment, permanent plug and abandonment, is that you are not going to re-enter the wellbore at all.
Okay.
That's the reason that I brought up this P&A to this geothermal and this well integrity intentionally, to tell you that the same phone call that I got from a reservoir depleted is a good candidate. It was plug and abandoned. Not only the wellbore. Okay, you tell me, Mahmoud, I have a reservoir. It has been plugged and abandoned. I don't give a damn. I'm going to drill another wellbore somewhere else into this reservoir, a new wellbore. And I will construct it based on the application, which is geothermal now. I tell you, okay, perfect. But you are going to inject fluid to recover heat. How sure are you that the injected fluid does not leak through the old wellbore, which we call it loss of energy? So If you have a plugged and abandoned well permanently, you cannot re-enter it. Forget about that. And if you want to use it as a source of heat recovery, then you need to go back and check the P&A design to make sure that that wellbore is capable, or the plugs, barriers, primary and secondary barriers placed close to the reservoir are capable to hold the pressure for you. And remember, when we do plug and abandonment, we design these barriers, primary and secondary barriers, to hold the maximum pressure, which is equal to the original reservoir pressure and sometimes is equal to the current reservoir pressure. You cannot exceed that pressure. Then those barriers, they're gonna fail, and since you cannot control the fluid, you go on loss of heat.
Okay. Thank you. Yeah. Thank you. Thank you.
You're welcome.
That answered my question. Anyone else in the audience has any questions?
Yes, I
Okay.
do.
Yes.
Can you hear me?
Yes, please go ahead.
Yes, Jamal.
Okay, sorry.
Please go ahead.
Thanks, Dr. Mahmoud, for your presentation. Coming from the national oil company mentality, we were not plugging the wells, we were using them as an observation well. My question is, Norwegian part, are they basically part of the national oil company? Cannot they actually keep them as it is and as an observation well? This is one
Okay.
question. And then the
Yeah.
second question is, uh, here when we plugging the well, we put 2 or 3 sets of plugs and removing the casing, the production one. And this is kind of the cost saving and make the plugging cost, lower. It's kind of incentive for the plugging company. Is it the same procedure in Norway? Because you mentioned in Norway, because you mentioned you have more of the offshore wells. Just your comments. Thank you.
Yes. Thanks a lot. Actually, you are raising two interesting questions because, as you know, all of these wells in Norway are national. It's not like US where you have actually
Yeah.
private companies, owning the reservoir, a reservoir. And at the same time, as I mentioned, all of the wells in Norway are offshore wells. Okay. When a reservoir is depleted, you don't have intention or you don't want to leave the wellbore active and having, for example, a platform or subsea well as an observation well. Okay, it doesn't make any sense to send a ship or let's say personnel to a platform. And you need remember, you're talking about asset integrity. You have to take responsibility for the platform for the wellbore. Okay? Therefore, we don't have any intention. If the wellbore is damaged, we do a slot recovery operation. If the field or reservoir has been depleted, we do permanent P&A and we just
Okay.
decommission the platform. Talking about number of plugs, up to a few years ago, up to 2016 or 17, actually in Norway we had a conventional approach. Conventional approach means for every source of potential, source of flow, which has a potential, and it's a hydrocarbon, we were installing two plugs, two permanent plugs. I'm not talking about putting cement inside casing, no, from rock to rock. Over times, we learned from Oil and Gas UK guidelines from the UK sector that you can do risk assessment. Sometimes you can combine reservoirs and establish primary and secondary barriers for the top reservoir, and you allow cross flow. But remember, if you come from countries that they have land wells like US, like in Middle East, okay, like Canada, you have groundwater. Your task is more difficult because water for you is the oil in the future, or maybe already is. Any leak to the groundwater means that you challenge your company and its reputation. So, talking about Norway, now we are using risk-based approach. Risk-based approach means that if the flow, the pressure, reservoir pressure, current reservoir pressure, or future reservoir pressure, if it's high and can frag formations above, then we would prefer to place two permanent barriers close to the reservoir. If not, we use the risk-based approach to reduce the number of plugs.
Okay, very good. Interesting.
Thank you.
I have a quick question. It's more of a clarification than other things. You mentioned challenges regarding casing elongation, or
Yes.
about 2 meter at some point. How does that happen? Just is it a problem with the drilling engineer or how they designed the well, or you go ahead? Sorry.
Okay, so let me make it very simple for you. You have a geothermal gradient, correct? Okay, you drill your wellbore. You place the casing shoe. Usually when we place the casing shoe, we pull off a little bit, a few meters, and then we do cementing. But remember, we are talking about bottom hole circulating temperature and bottom hole static temperature. Bottom hole static temperature is a geothermal gradient. Bottom hole circulating temperature during well construction means that temperature is below the static temperature. However, when you start with production or when you complete your wellbore, the bottom hole circulating temperature, which was actually cooled down during drilling, will go to its static temperature, which is geothermal, or during production, the upper sections, they will get hotter. So the temperature will rise. And then actually your casing starts to expand. So you have to calculate what is the maximum temperature which your casing will experience. But at the same time, if you do half and puff, then you need to know what's the minimum and what's the maximum temperature. It means that you give thermal cycling. Even I doubt if this current well design, they're gonna help you for half and puff technique, for example. I'm not quite sure if you can have any cement even.
Okay.
Yes.
All right. Thank you.
Thank you.
Okay, I think that Dr. Khalifeh, thank you so much. Thank you so much for your time, for addressing our questions, and presenting this very interesting topic that definitely needs to be probably we need to make a lot of attention, especially thinking about this industry that the wells, the life, the life of those wells are expected to be much longer compared with oil and gas wells. So well integrity is an important thing that we need to keep an eye on it. And you introduce very nice concepts, and this is a very instructive presentation. Thank you so much.
Thank you so much, Vivas. And Said, thanks a lot for the opportunity. You guys, you can get my contact information from Dr. Said. And if you have any questions, feel free to contact us. And through this SUIPA, if you want to visit us, you're more than welcome. And looking forward to hearing from you in the future. And good luck with your subject, the course, and also with your future.
Mahmoud, can you please share your slides so we can upload for students?
Yes, of course. I'll do it right away.
Yeah. Thank you very much.
Thanks a lot.
Have a good
nice
evening.
day. Thanks.
Bye.
Like, all right. Thank you so much.